the slowest light in the universe. The journey begins in silence, a silence older than stars, older than atoms, older than anything that has ever learned to ask a question. The camera glides through a star-dusted emptiness where distances stretch until language breaks, where numbers lose their meaning, and where even imagination hesitates at the threshold of scale. From the surface of a distant star, a single photon quivers into existence. It does not know its purpose. It does not know its destination. It only moves, compelled by the immutable rules written into the bones of spacetime itself. Its voyage is cruelly slow. Across centuries, it will cross nothing. Across millennia, it will cross almost nothing. Civilizations may ignite and extinguish in the time it drifts through a fraction of a single light-year. Entire star systems will be born, live, and crumble into dust before its journey marks any measurable progress. The narration lingers on this fragile truth. Humanity's instinct to measure and understand is not a sign of mastery, but of defiance. The universe does not accommodate comprehension. It does not simplify its scale. It offers distances so vast that intuition shatters against them. Light years large enough to dwarf history, to erase context, to stretch cause and effect into cosmic abstractions. Some stars whose light touches Earth today died before insects walked upon continents. Some galaxies whose shapes fill telescopes drift apart faster than the speed of understanding itself. Every glance at the night sky is a glimpse into a past so unreachable it becomes myth. And in that ancient light lies a question heavy enough to anchor the soul. What does it mean to exist in a universe where even light, the fastest thing ever known, is unbearably slow? Across the ancient world, long before the idea of distance carried the weight of numbers, the night sky hovered as a vast and inscrutable canopy. Pinpricks of cold fire drifted in slow seasonal choreography, their patterns memorized by shepherds, navigators, and priests. In Mesopotamia, stone tablets were etched with patient records of wandering lights. In Greece, philosophical minds debated the nature of celestial spheres, imagining crystalline shells upon which the stars were pinned. In China, court astronomers kept meticulous logs of guest stars, supernovae whose true nature would not be understood for millennia. Yet beneath all of these early attempts at comprehension lay a single, unspoken assumption. The stars belonged to a realm close enough to grasp, a reachable heaven merely placed beyond a dome of air. The cosmos, to ancient eyes, was a masterpiece of proximity. Distance did not frighten. It was never conceived as a force capable of overwhelming the mind. Even the faintest stars were assumed to be relatively nearby, glowing lanterns hung just beyond the earthly winds. Their twinkling was interpreted as the shimmering of their surfaces, not the distortion of their light by a restless atmosphere. The human imagination, still bound to the scale of mountains and seas, had no vocabulary for the impossible gulfs that lay between worlds. Yet something in the heavens resisted those early interpretations. A subtle variation here, a drifting brightness there, clues so delicate they could slip past generations of observers. Among these clues, the slow shifting of stars relative to one another, a motion too small to perceive without instruments, hinted that the sky was not a fixed tapestry but a deep ocean layered with unimaginable space. Humanity lacked the tools to see this truth, but the universe waited patiently, as it always does, for minds and instruments to evolve. Centuries passed. Empires rose and dissolved. Curiosity endured. Glass lenses began to reshape human perception. At first simple and flawed, telescopes grew into refined portals, each iteration stretching the boundary of the visible universe a little farther. As telescopes sharpened, the once familiar constellations began revealing faint companions and hidden depths. Packed star clusters dissolved into thousands of distant suns. The Milky Way, once a soft river of celestial mist, fractured into individual stars, each emitting its own ancient light. Still, even with improved vision, distance remained elusive. Astronomers could see farther than ever before but could not say how far truly was. The night sky, though revealed in greater detail, continued to conceal its scale. Humanity had reached a threshold where sight alone was not enough. A new kind of thinking was required. something mathematical, patient, and audacious enough to measure the immeasurable. In the early 19th century, Europe's observatories stood as quiet sanctuaries of this new scientific ambition. In narrow, chilled rooms filled with brass instruments and the scent of oil lamps, a small number of astronomers attempted a feat long considered impossible. They sought to measure the distances to the stars themselves. Among them was Friedrich Wilhelm Bessel, a German mathematician whose profound precision and unyielding patience would alter the trajectory of cosmic understanding. Bessel understood a simple but revolutionary idea. If Earth moved around the Sun, then nearby stars should appear to shift slightly against the background of more distant stars. This effect, stellar parallax, had been theorized for centuries but never detected. The shift was astoundingly small, far below the limits of earlier telescopes. Many astronomers believed it would forever remain beyond reach. But Bessel believed otherwise. He recognized that only the tiniest, most stable instruments could reveal the subtle wobble of the heavens. At Königsberg Observatory, he selected a single star, 61 Cygni, a faint, modest point of light in the constellation Cygnus. It was not the brightest, nor the most striking. It was simply a star whose motion through the sky suggested proximity. Using a heliometer, a device of unprecedented precision, Bessel spent endless nights recording the star's position with monastic discipline. Each measurement was a fragile dialogue between man and cosmos, a question etched delicately into the machinery of observation. Months passed. Seasons turned. Earth continued its orbit. Slowly, the tiniest whisper of a shift emerged, a fluctuation so unimaginable that many would have dismissed it as error. But Bessel persisted, refining, confirming, calculating. By 1838, the results could no longer be denied. 61 Cygni displayed a parallax of 0.314 arcseconds. From this, Bessel derived its distance, more than 10 light-years away. In that moment, the universe changed. Humanity had measured the heavens not by myth or metaphor but by geometry and light. And what that measurement revealed was staggering. Even the nearest star lay at a distance so immense that its light, traveling at nature's ultimate speed, required more than a decade to arrive. The true scale of the cosmos began to unfurl, not through a sudden revelation, but through a quiet revolution in understanding. A star once believed to hover just beyond reach was, in truth, separated by trillions upon trillions of kilometers, distances so vast that human intuition dissolved upon contact with the numbers. Bessel's measurement shattered the ancient model of a compact, easily understood cosmos. For the first time, distance became a force, a cosmic truth of overwhelming magnitude. Other astronomers soon followed. Thomas Henderson measured Alpha Centauri. Friedrich Struve studied Vega. Each new distance added another layer to the expanding map of the sky, and with each revelation, the scale of the universe grew colder, larger, and more incomprehensible. What had once been a poetic canopy now stretched into a silent abyss. Photography entered the scene, replacing hand-drawn sketches with permanent records of starlight. Photographic plates captured faint stars invisible to the naked eye. Mechanical micrometers traced their subtle motions. The night sky transformed into an archive of data, each image a frozen echo of light that had crossed impossible distances. The cosmos was no longer an artistic metaphor. It was a measurable, chartable expanse far beyond human proportions. But something deeper shifted as well. The human mind, once comfortable in a universe scaled to myth and meaning, now confronted an expanse so vast it strained the boundaries of comprehension. Distance ceased to be merely a measurement. It became an existential presence. Light years, a term yet to gain its modern weight, began to emerge as the most humbling unit ever conceived. Humanity had crossed a threshold from which it could never return. The sky had grown immeasurably larger. The stars had drifted immeasurably farther. And in expressing their separation, the universe had quietly revealed its true nature, immense, ancient, indifferent, and governed by distances so deep they would one day break the limits of human understanding. The discovery of cosmic distance did not arrive with thunder or proclamation. It came instead as a series of faint, nearly imperceptible shifts in the positions of stars, tiny motions that carried within them the collapse of old assumptions and the birth of a new cosmic order. History turned not in a moment of spectacle, but in the careful alignment of numbers, observations, and quiet realization. Through Bessel's work and the efforts that followed, humanity lifted the first veil concealing the true architecture of the universe. The cosmos had revealed its first secret. The stars were not neighbors but distant islands separated by oceans of darkness. With that revelation came a subtle chilling of the cosmic landscape, a realization that the universe was far larger, far older, and far more remote than anyone had imagined. The sky had expanded in the human mind, and with it, the mystery of light years emerged, a mystery that would unfold into something far more unsettling. The recognition that even light, swift as it is, remains too slow to bind the universe together. The discovery phase had ended. The age of cosmic distance had begun. The shock did not arrive like thunder. It arrived as silence, a deep, cold silence that settled over the scientific world when the true scale of the cosmos began to reveal itself. For centuries, humanity had gazed upward believing the stars were ornaments of a nearby heaven, luminous points scattered across the celestial ceiling. But with each new measurement, with each refinement of parallax and each carefully mapped stellar drift, the universe began to reshape itself into something far more unsettling. A realm so vast that ordinary intuition simply collapsed upon contact. The camera widens into a slow drift through a dark stellar plane, where ancient light travels indifferent to those who seek to measure it. The closest stars, once imagined as companions hovering just beyond reach, now stand revealed as remote suns suspended in oceans of interstellar emptiness. Their distances are not simply large, they are offensive to the human sense of scale. It is here, in this widening abyss, that the first true fracture in human intuition occurs. Astronomers studying stellar parallax confronted the unimaginable. Even the nearest stars lay trillions of kilometers away, so far that Earth's entire orbit around the Sun carved only the slightest wobble in their positions. These minuscule shifts, mere fractions of an arcsecond, were the only clues to stellar distance. Their very smallness was an insult to expectation. If the stars were truly so distant, then everything humanity had believed about the structure of the cosmos was profoundly incomplete. The shock spread quietly across observatories, letters, and academic halls. Data from Bessel, Henderson, and Struve circulated across Europe, each new calculation reinforcing the same absurd revelation. The universe was enormous beyond comprehension. And then came the deeper blow, the finite speed of light. For centuries, the speed of light was either unknown or assumed infinite, a natural intuition reinforced by everyday experience. No sense organ registered delay, no earthly distances were large enough to expose the truth. But experiments by Ole Romer, James Bradley, and later Albert Abraham Michelson began to chip away at this illusion. Light had a speed, a definite, measurable speed, and it was fast, but not infinitely so. Its finiteness changed everything. The camera shifts into a slow passage through the vacuum, following a lone photon escaping the surface of a distant star. It drifts for years, then decades, then centuries. It witnesses nothing. It feels nothing. It simply endures. The star that released it may flare, dim, or die, but the photon continues on, indifferent to the fate of its origin. When this truth settled into scientific consciousness, the sky transformed. The stars were no longer present-day objects. They were messages from the past. Their light was ancient. Their images were memories. The universe itself was revealed not as a live panorama, but as an archive of delayed signals. Humanity had been looking into the past without knowing it. The implications rippled outward. Events observed in the heavens were not happening now. They had already happened, sometimes long ago. The bright blue star Rigel sent light that was hundreds of years old. The gleaming arch of Andromeda carried photons that had traveled more than 2 million years. The universe, in a very real sense, was filled with ghosts. This realization was a cosmic insult. Human perception was fundamentally inadequate. The senses had been overruled by physics. The universe refused to be seen as it truly was. And then Albert Einstein entered the stage. Relativity did not merely reinforce the finite speed of light. It elevated it into the central commandment of the cosmos. Nothing, no particle or piece of information, could travel faster. The speed of light became the universal speed limit, woven into the geometry of spacetime. The scientific shock deepened into crisis. The cosmos was not only vast, it was ruled by a law that made crossing its vastness nearly impossible. Galaxies, stars, nebulae, all were isolated by distances so immense that even at the ultimate speed, traversal was futile on human timescales. The light year, once a simple unit of measurement, became a monument to cosmic inaccessibility. Relativity revealed that even the flow of time itself bowed before these distances. Time dilated for clocks in motion. Space-time bent around mass. Gravity sculpted the paths of photons. The universe was not a stage but an active participant, and distance was its most merciless instrument. Early physicists resisted. Some insisted the measurements were wrong. Others argued that the distances were too large to be real, that parallax must be flawed, that the cosmos could not possibly be that big. But as more telescopes were built and more data arrived, the objections faded. There was no escape from the conclusion. The camera glides past the remnants of ancient stars, supernova debris expanding into silence, shockwaves frozen in slow motion. These cosmic tombs testify to light's delay. Many such explosions were never seen by the civilizations present when they occurred. Their signals arrived long after the stars had died. Humanity's window into the universe was staggeringly, irreversibly delayed. Astronomers stared into telescopes knowing the universe they observed might not exist anymore in the form they saw. Galaxies could have collided. Stars could have extinguished. Nebulae could have dispersed into darkness. But their light continued to paint illusions across Earth's sky. Beautiful, yes, but fundamentally outdated. This was the moment when cosmic distance became a psychological weight. Scientific journals filled with descriptions of diluted starlight, ancient photons, and temporal displacement. Philosophers wondered what it meant to inhabit a universe where reality arrived late. The night sky, once a source of comfort, became a reminder of cosmic loneliness. The distances were too large for travel, too large for communication, too large even for imagination to hold without fracturing. And deeper still lay a more disturbing truth. The farther humanity looked, the older the universe appeared. The cosmos was not static. It was not eternal. It had a past, a beginning, a trajectory. And all of this knowledge flowed from the simple, brutal fact that light required time. The camera now drifts toward distant galaxies whose shapes smear under relativistic stretching. Their redshifts, once puzzling, now revealed their recessional speeds. The expansion of the universe came into focus. Space itself was growing. Distances were increasing with time. The light humans observed came from a universe that no longer existed in its observed form. This was the ultimate shock. Distance was not merely large. It was dynamic, evolving, accelerating, and indifferent to human psychology. The more scientists measured, the more absurd the scale became. Tens of light years became hundreds. Hundreds became thousands. Thousands bloomed into millions, then billions. The observable universe swelled into a 93 billion light-year wide sphere of ancient light, an arena so large that direct understanding became impossible. Cosmic distance had outgrown the human brain. Astronomers who studied deep space sometimes describe the experience in letters and private notes. A mixture of awe and something more fragile, a quiet trembling beneath the grandeur. The universe was not hostile. It was simply enormous, and that enormity was enough to undo certainty. The shock of cosmic distance was not a single moment. It was a slow unfolding, a revelation layered over centuries of observation, measurement, and intellectual courage. Each new discovery forced humanity to surrender another comforting illusion. Each new measurement drove home the same truth. The universe was vast beyond logic, and light, though swift, was painfully slow against the architecture of spacetime. In the end, the shock was not about numbers or units. It was about realizing that reality itself is fragmented by the limits of light. The universe humans see is a mosaic of times, a composite of ancient signals stitched together into a grand but misleading portrait. And in that portrait lies the first true crack in human understanding, the recognition that distance is not passive. It manipulates perception, obscures truth, and reveals only echoes of what once was. In this chapter of cosmic awakening, humanity was forced to confront a profound and humbling realization. The universe is not just larger than imagined, it is structured in such a way that true presence, true simultaneity, is impossible across its expanse. And thus, the scientific shock settled in. Light years were not merely measurements. They were boundaries, vast, merciless, and permanent. The deeper the investigation went, the more the universe behaved like a vast and ancient cathedral, one whose halls grew larger with every step taken into its darkness. Each new measurement lit only a narrow corridor, and beyond that corridor, more shadows stirred, more immensity waited, more questions unfolded into silence. The chapter begins not with a breakthrough, but with a gentle flicker, the rhythmic heartbeat of a distant star. Cepheid variable stars, their brightness pulsing in steady intervals, became luminous metronomes scattered across the heavens. When Henrietta Swan Leavitt first uncovered the relationship between their period and intrinsic brightness, she unknowingly handed astronomers a cosmic yardstick. As the camera drifts past a golden cepheid embedded in the hazy petals of a distant nebula, its glow expands and contracts like the breath of a sleeping giant. Each pulse becomes a message. This is how far I am. This is how vast the dark between us truly is. Cepheids recalibrated everything. Distances once guessed became distances measured. The Milky Way, once thought to encompass the universe, was demoted to a single island of stars. But even this revelation was merely the threshold. When Edwin Hubble set his sights on Andromeda using the 100-inch Hooker telescope at Mount Wilson, he recognized Cepheids in its swirling structure, and thus measured a distance so immense that it shattered the remaining illusion of a universe composed of only one galaxy. The cosmos expanded overnight into a vast archipelago of galaxies adrift in an ocean of spacetime. The camera sweeps outward now, drifting past the spiral arms of Andromeda, crossing into intergalactic voids where starlight thins and silence grows. The distances between galaxies dwarf the distances within them. Even the most powerful bursts of light fade into whispers as they attempt to bridge the yawning gulf. Redshift measurements extended this ladder further still. Light stretching toward the red end of the spectrum signaled motion, galaxies drifting away, the universe itself growing. The deeper astronomers looked, the more space expanded ahead of their gaze, as if the cosmos continually retreated from comprehension. Here begins the descent into true investigation. Not merely measuring distance, but confronting the machinery of an expanding universe. The Palomar Observatory, with its 200-inch Hale telescope, opened another window into this expansion. With each photographic plate, astronomers recorded galaxies fainter, smaller, and more distant. These light signatures, barely visible smudges, represented worlds billions of years removed from the present. The plates accumulated like geological layers, shards of ancient light stacked across time. Each smear of faint brightness was the echo of something vast, a supercluster collapsing, a starburst igniting, a quasar feeding on the heart of a supermassive black hole. The deeper scientists looked, the older the universe became. But the layers did not align. Conflicts arose within the cosmic distance ladder, disagreements between parallax, Cepheids, Type Ia supernova measurements, and redshift interpretations. Even today, the Hubble tension persists. Different measurement methods yield different values for the expansion rate of the universe. This dissonance is not noise. It is a whisper from the cosmos, hinting at new physics lurking beneath the visible. As the camera glides through interstellar dust, across the arcs of supernova remnants and into the abyss of intergalactic voids, it becomes clear that every rung of the distance ladder carries its own uncertainties. Some Cepheids flicker irregularly. Some supernovae shine brighter or dimmer than expected. Some parallax measurements defy prediction. The cosmic ladder sways, creaks, and shifts, a structure built upon signals that have traveled a long, uncertain journey. Then comes the modern era. The Hubble Space Telescope, drifting above Earth's atmosphere in sublime stillness, captured light so faint it bordered on non-existence. The Hubble Deep Field, a tiny patch of sky no larger than a grain of sand held at arm's length, revealed thousands of galaxies hidden in the darkness. Not stars, not nebulae, galaxies. Each one an entire cosmos of its own. The shot widens. Billions of galaxies flicker into view, layered in bands of increasing distance. Some appear crisp and spiral, others blur into faint, reddened ghosts stretched to transparency by the accelerating expansion of space. The scale grows intolerable, yet science pushes deeper still. Gaia, the European Space Agency's precise astrometric observatory, brought an unprecedented level of clarity to the measurement of stellar distances within the Milky Way. Gaia does not take pictures. It takes positions, billions of them, each a data point in a map so vast that it rivals the scale of human imagination. Gaia's measurements revealed intricate patterns of stellar motion, tidal streams from dissolved galaxies, the subtle drift of the sun's neighborhood, the dance of stars bound to the Milky Way's gravitational field. But these revelations also uncovered new puzzles, unexpected oscillations, peculiar clumping, distortions in stellar populations, all pointing to undiscovered mass or unseen gravitational influences. The deeper the investigation went, the less the cosmos resembled a calm, predictable system. Instead, it behaved like a living structure shaped by forces still unknown. At the furthest edges of reach, astronomers detected faint whispers of galaxies whose light had traveled more than 13 billion years. These primordial structures were small, chaotic, and intensely bright. Cosmic infants forged when the universe was young and turbulent. But even these glimpses were fragmented. Some galaxies appeared too massive too early. Others formed stars too rapidly. A few seemed to challenge the timeline of cosmic inflation. Every new observation added another layer of complexity. The mysteries multiplied. And then came the most profound discovery of all. The universe is not merely expanding, it is accelerating. Measurements of distant Type Ia supernovae revealed unexpected dimming. These explosions, long used as standard candles, appeared farther away than predicted by a universe expanding at a constant rate. Something was pushing galaxies apart faster and faster. Dark energy entered the lexicon, a term for an unknown force, invisible and pervasive, that stretched the fabric of spacetime. It accounted for nearly 70% of the universe, yet no instrument had ever detected it directly. The camera moves through a cosmic web, filaments of galaxies strung like veins across a void thousands of light-years wide. In these vast structures, the accelerating expansion becomes apparent. Clusters drifting, superclusters separating, the large-scale architecture increasingly strained by unseen forces. Scientists dove deeper into this abyss, seeking patterns in the cosmic microwave background, distortions in gravitational lensing, and imprints left by baryon acoustic oscillations, the echoes of primordial sound waves that once rippled through the early universe. Each dataset offered clues yet no consensus, as though the cosmos were offering riddles rather than answers. Even the parallax measurements, once considered the bedrock of distance, began to conflict with other methods. The cosmic distance ladder, the entire scaffold upon which the scale of the universe was built, wavered under the weight of new data. And at the farthest observable frontier, where light fades into near-nothingness, the edge of visibility trembles. Here, galaxies stretch into red, then into infrared, then into wavelengths so faint that only the most sensitive detectors can sense their dying echoes. Beyond this limit lies not darkness, but information erased by expansion. Space itself grows faster than light can cross it. These regions are lost, unreachable, unseeable, forever receding. This is where the investigation turns philosophical. Each layer peeled back reveals not an answer, but another boundary. The deeper the inquiry, the more the universe behaves like an infinite lens, magnifying human curiosity while hiding its own architecture. It is not merely large. It is increasingly large. It grows with time, with distance, with perspective. It grows with every attempt to understand it. Thus emerges the unsettling conclusion: there may never be a final cosmic map. The universe expands faster than it can be charted. The horizon recedes faster than it can be measured. The investigation, by its nature, will always be incomplete. Yet this incompleteness does not diminish the pursuit. It elevates it. For in the spaces between galaxies, in the faintest whispers of ancient light, and in the discrepancies of the cosmic distance ladder, the universe reveals its deepest truth, not in certainty, but in the invitation to search. Every instrument built by human hands, from Palomar to Hubble to Gaia, reaches into the abyss with the same quiet question: how far does the cosmos truly go? And in the silence that follows, the universe answers only with more distance, more mystery, and the soft, eternal glow of ancient stars still making their way across the dark. A quiet unease settles over the universe as the camera drifts through a field of distant galaxies, vast island realms suspended in a darkening tide. Their shapes glow faintly, like embers drifting from a cosmic fire long since extinguished. Their light is ancient, their movements silent, their destinies sealed by a force no human instinct ever anticipated. It is here, in this dim frontier of cosmic vision, that a revelation emerges, one that unsettles even the most disciplined minds. For the universe is not merely expanding, it is accelerating. The fabric of space does not drift outward, it surges. Whole galaxies retreat not through space, but with space. Their flight is not a choice but an inevitability carved into the geometry of existence. And as the expansion quickens, something strange unfolds. Light itself begins to fail. Photons, the messengers of distant events, stretch into invisibility as the cosmos pulls them apart. Beacons once bright collapse into darkness. Structures once observable dissolve beyond the reach of any telescope humanity could ever build. In this widening abyss, a profound truth emerges. Much of the universe is already gone. Not destroyed, not absent, simply unreachable, sealed behind an expanding horizon. The cosmos reveals itself not as an open landscape, but as a vanishing one. Every second, more of creation is swallowed by distance's accelerating hunger. The crisis is not merely scientific. It is existential. For the first time, humanity confronts a universe in retreat, a universe that, piece by piece, is slipping beyond the possibility of being known. The camera glides through a silent quilt of intergalactic darkness, passing clusters of galaxies arranged like frost patterns on an ancient windowpane. Their light flickers with the faint fatigue of unimaginable age. Here, the distances are no longer measurements but thresholds, barriers shaped by the universe itself. What lies beyond them is not hidden by instruments or ignorance, but by the laws of nature. This is the frontier at which cosmology enters its crisis. For centuries, distance had been a concept of scale, a matter of size, of separation, of how long light required to cross the vacuum. But in the early 20th century, a deeper revelation began to unfold. Space was not static. It was alive, stretching in every direction. In Edwin Hubble's measurements, scientists glimpsed the first tremors of a cosmic truth. Galaxies were not merely drifting, they were being carried by an expanding universe. At first, the numbers seemed manageable. Tens of thousands of kilometers per second. Then hundreds of thousands. A quiet discomfort grew, yet the equations held. The redshifts grew larger, the logic grew stranger. And as measurements sharpened, through spectroscopy, through supernova light curves, through the silent patterns of cosmic microwave background ripples, an unsettling pattern emerged. The further a galaxy was, the faster it fled. The universe was not only expanding, it was accelerating. As the narration deepens, the camera sweeps past a spiral galaxy whose halo shimmers like scattered glass. Its arms twist slowly, yet the space around it stretches relentlessly. The galaxy drifts backward into the darkness, its light thinning, its presence fading. Einstein's equations had quietly predicted such behavior, buried within the form of the cosmological constant. But decades of skepticism had pushed the idea aside. It took a meticulous analysis of Type Ia supernovae to uncover what had always been embedded in the very structure of space-time: an unseen pressure, a hidden engine, dark energy, driving the universe apart. And with that discovery came a new kind of distance. Not geometric, not observational, but existential. The acceleration meant that the universe contained regions moving away faster than light. Not violating relativity, nothing outraced light through space. Instead, space itself expanded so rapidly that light could no longer bridge the growing gulf. This was the birth of the cosmic event horizon. A boundary not of matter, but of destiny. Beyond it, galaxies slipped into irretrievability. Their light, stretched thin by expansion, dimmed into microwaves, then into radio whispers, then into silence. No future telescope, no innovation imaginable, could reclaim them. Their final photons would never reach us. Their existence would become a rumor, then a memory, then a conceptual abstraction. The camera drifts toward one such vanishing galaxy, a faint elliptical shape receding through a haze of cosmic dust. At the edges of visibility, it flickers. Its redshift is deep, its spectrum stretched into near oblivion. It is a ghost in real time, receding faster than its own light can compensate. Within a few 100 million years, it will disappear forever, still out there, still real, but cut off by the accelerating tide. This is the crisis that haunts modern cosmology, because the implications are profound. For the first time in history, scientists are forced to confront not merely what the universe is, but what it is actively removing from reach. The cosmos does not simply exist, it edits itself. It erases access to its own majority. The observable universe, the only portion humanity can ever study, shrink in relative proportion with every passing epoch. The emotional undercurrent flows like a quiet ache through the narration. Not fear, not despair, but a recognition of fragility, of the narrowness of our cosmic window. The camera shifts. A sudden panorama appears. The cosmic web, glowing like an enormous neural network suspended in a void. Luminous filaments stretch for millions of light years, dotted with galaxies. But along its edges, the glow fades. Those outskirts are not dim because they are empty, they are dim because they are gone. Physics now speaks in the language of horizons. Not metaphors, mathematical surfaces through which information cannot pass. The cosmic event horizon, roughly 16 billion light-years away, is the boundary beyond which light emitted today will never reach Earth. Even as the universe grows to trillions of light-years across, this horizon remains fixed, rigid, a wall etched into the fabric of spacetime. And beyond it, the vast majority of galaxies, nearly all that ever existed, are already unreachable. The narration slows. The camera holds on the cosmic microwave background, glowing faintly like the cooling embers of creation. Its ripples encode the universe's earliest structure, tiny fluctuations that would grow into stars, galaxies, and clusters. But even this primordial map is bounded. It shows not what lies beyond, but what lies before. Humanity stands inside a shrinking bubble of cosmic information. What remains accessible is a fraction of a fraction. A local supercluster, a scattering of galaxies, a thin slice of cosmic history. The rest recedes at superluminal rates, stretching into invisibility. Every second, the horizon sharpens. Every second, more of the universe slips beyond reach. Every second, the knowable cosmos contracts, not in size, but in proportion to all that exists. Scientists confront an unsettling philosophical question. What does it mean to study a universe that is actively receding from knowability? Cosmology has always relied on the assumption that the universe is discoverable, that with time, with data, with patience, its secrets would unfold. But the accelerating expansion challenges that premise. The universe is not a static puzzle waiting to be solved. It is a dynamic, evolving structure that withholds information as quickly as it once revealed it. The camera dives into the interstellar void, where galaxies once visible have faded into cold shadows. No movement is seen. No light flickers. This is not emptiness. It is distance transformed into silence. Deep inside this silence lies the ultimate tension. The universe is larger, faster, more violent in its expansion than human comprehension evolved to grasp. The crisis is not merely observational. It is conceptual. Distance has ceased to be a measure of space. It has become a measure of possibility, a limit, a boundary, a cosmic verdict. The chapter closes as the camera withdraws from the deep void, returning to the faint glow of nearby galaxies. Their light is warm, familiar, comforting, an oasis in an ever-expanding wilderness. Humanity's future is confined to this oasis, yet the mystery beyond its edges continues to deepen. For every discovery, the horizon recedes. For every answer, the distance grows. And in this accelerating separation, the universe delivers its most haunting revelation. The majority of creation will forever remain beyond reach, beyond vision, beyond understanding. Lost not to destruction, but to distance itself. The mystery does not end here. It expands. It accelerates. It outruns the very light that seeks to reveal it in the quiet aftershock of discovery. When distance itself had become an adversary, the universe presented its most enigmatic question. What kind of reality allows such impossible separation? The camera drifts through a trembling lattice of starlight, each beam stretched thin by cosmic expansion, each photon carrying not only ancient memory but also the imprint of a universe straining against its own origins. Distance is no longer a passive measurement. It is a phenomenon, a force, a sculptor of fate. Here, in this vast silence, humanity turns to theories not as answers, but as lifelines. Einstein's equations curl like gravitational eddies around massive stars, bending the path of light and revealing that straight lines are illusions. Hawking's horizons rise like dark event boundaries across the cosmic scene, suggesting that even information has limits, and that distance is sometimes a form of exile. Quantum fields ripple beneath everything, a restless ocean whose fabric stretches the very wavelengths that seek to cross it. Dark energy accelerates galaxies apart with a cold patience, widening abyss after abyss. Inflation theory pushes the narrative deeper still, a universe born expanding faster than light itself, distances forged in an instant so extreme they defy metaphor. And beyond that, in the wild frontier of speculation, multiverse theories whisper of distances that are not merely large, but meaningless. Fragments of reality separated by barriers more profound than space. Each idea illuminates a corner of the mystery, yet none completed. The universe remains unsolved, a grand riddle etched across horizons too distant to ever touch. Distance has become a tyrant, and in the search for its origin, science turns to its deepest wells of thought. The camera floats through a cathedral of cosmic structures, galaxy clusters like drifting archipelagos, filaments stretching across hundreds of millions of light years, voids yawning like caverns between realms. Every structure vibrates with a single question: how can a universe be so large, so separated, yet so unified by the laws that govern it? The journey begins with special and general relativity, the twin frameworks through which Einstein reimagined the fabric of existence. Relativity presents space-time not as empty geometry, but as a living stage that bends, curves, and stretches. Mass pulls the grid downward, energy ripples through it like waves on a taut sheet. Distance becomes elastic. Light, once thought absolute in its straight-line purity, arcs around stars and galaxy clusters, producing mirages, gravitational lenses, that warp the very notion of where things are. In this cosmic ballet, distance is no longer a simple measurement. It is geometry itself, reshaped by matter and motion. A beacon's light may travel a billion years, but under relativity, that path is twisted by every galaxy cluster it encounters, every dark halo it grazes. The vastness is therefore not just physical but conceptual. Nothing in the universe is truly where it appears to be. Next arises the shadow domain of Hawking's frameworks. The camera drifts toward a supermassive black hole, its event horizon a dark ring of inevitability. Hawking revealed that horizons are not merely boundaries of gravity, but boundaries of information. Beyond them, signals fade, communication ends, and causal contact is severed. The black hole becomes a metaphor and a literal demonstration of the universe's greatest truth, that there exist distances so profound they are physically unreachable no matter how long light travels. Cosmology expands this idea on the grandest scale. The universe, too, has horizons, regions forever cut off by expansion, places from which no light will ever reach. These horizons grow with time, swallowing galaxies not through destruction but through separation. Hawking's mathematics echoes, information lost not in a singularity, but in the unstoppable stretching of space. Beyond relativity's domain lies the trembling energy beneath reality, the quantum fields. Here, distance becomes a behavior of the vacuum itself. Every particle, every photon, every force emerges from fields that never rest. This quantum substrate underlies the expansion of space, a faint hum that grows louder as the universe ages. The camera sinks into a microscopic sea, fluctuations bubbling like sparks in darkness. As space expands, wavelengths stretch, signals weaken, and the very identity of light dilutes. It is quantum fields that define why distant galaxies glow redder with time. Their light is elongated by the stretching fabric, an elegy to the spaces that grow between all things. Yet no idea reshaped the concept of distance more dramatically than dark energy. This invisible pressure, discovered at the end of the 20th century, accelerates the expansion of the cosmos. It pushes galaxies apart at an ever-increasing rate, turning once reachable regions into unreachable ones. The camera glides across a cosmic web now thinning, its filaments drawn taut then stretched to breaking. Dark energy transforms distance from static backdrop into active force. It drives galaxies beyond each other's horizons, exiling them into cosmic solitude. Trillions of galaxies will vanish from view in the far future, not because they dim, but because space itself will outrun their light. In this way, distance becomes a dynamic, growing frontier, a kind of cosmic erasure. Behind dark energy lies a more primordial concept: inflation. Inflation proposes that in the first sliver of cosmic time, the universe expanded faster than light by unimaginable factors, doubling, tripling, expanding by orders of magnitude in microseconds. Distances that today span billions of light-years were once quantum fluctuations, stretched out like ink across an ever-expanding canvas. The camera shifts into that first fraction of a second. Space swells violently, folding and unfolding, driving regions apart with such ferocity that no light could hope to cross their boundaries. Inflation built a universe already too large to comprehend, a universe whose distances were born absurd. Inflation answers many questions, yet leaves behind a haunting possibility that the inflationary process never truly ended. That beyond the observable universe lies a vast ocean of other regions, other bubbles, each forever separated from ours by distances that mock the imagination. This leads to the most speculative and awe-laden frontier, the multiverse. Here, distance becomes not merely a measurement within a universe, but a barrier between universes. Some theories suggest each cosmic bubble is sealed away by expanding space. Others propose higher dimensional separations where distance as humans know it doesn't even apply. The camera drifts outward beyond the cosmic horizon into a realm no observation can penetrate, a domain shaped only by mathematics and philosophical daring. In such scenarios, the distances between universes are infinite not in kilometers or light-years, but in causal separation. No signal can cross. No information can travel. No meeting is possible. Distance becomes a metaphysical boundary, the ultimate silence. Across these theories, one truth emerges. Every explanation solves part of the mystery, and every answer deepens it. Relativity explains geometry, but not the driver of expansion. Quantum fields explain energy, but not its origin. Dark energy explains acceleration, but not its nature. Inflation explains vastness, but not why it began. The multiverse explains diversity, but not existence. The universe remains an unresolved symphony of distance, a cosmos where separation is baked into its birth, evolution, and fate. And so, the chapter closes with the camera drifting once more through darkness, passing galaxies that glow faintly against an ever-expanding sea. The theories swirl like constellations of ideas, bright and incomplete, illuminating pathways that lead deeper into mystery. For in a universe defined by incomprehensible distances, human understanding is not a final destination, but an endless pursuit across the widening gulf. The war against distance. Across the silent dark, the universe offers no shortcuts. Its distances stretch like ancient vows, immutable and indifferent, separating stars, worlds, and entire eras of cosmic history. Light itself, swift, pure, relentless, moves through the void with a kind of noble futility, forever chasing horizons that retreat faster than it can cross them. Every photon is a messenger, but most messages arrive bruised by time, stretched thin by expansion, and dimmed by the weight of eternity. And yet, in a small corner of a modest galaxy, a species refused to bow to this tyranny. It built glass eyes sharper than evolution ever required. It forged mirrors that could see the first dawn of galaxies. It crafted detectors so delicate they could sense the trembling of space-time itself. Here, the camera drifts across continents at twilight. Observatories gleam like watchtowers placed at the edge of the universe. Radio dishes sleep under the turning sky, vast petals awaiting the faintest whisper of a distant star. Laser arrays pierce the darkness, mapping worlds so far that their sunlight began its journey before civilization existed. What emerges is not merely technology, but defiance, an unspoken pact with the cosmos. If distance is the great adversary, then measurement becomes an act of rebellion. Every new instrument is a declaration of intent. The universe may be vast, but it will not remain unknowable. And so begins a chapter about tools forged from hope, precision, and the quiet determination of a species that dares to pull meaning from an indifferent sky. Distance has always been the oldest enemy of knowledge. It lies between galaxies like an invisible ocean, swallowing detail, distorting truth, and burying history beneath horizons no ship may cross. The universe expands, stretches, and dims its own past, ensuring that every observation is an act of recovery, an attempt to rebuild what time has already erased. Yet despite this cosmic cruelty, humanity constructs instruments that stand like lighthouses against the tides of space. Gaia, the cartographer of the galaxy. The camera fades into the halo of the Milky Way. A thin golden disk spins in the dark, its structure delicate, almost fragile. Within this spiral vastness, a single machine traces the slow ballet of stars. Gaia. Suspended in a quiet orbit around the Sun, it performs a task once thought impossible, measuring the positions and motions of more than 1 billion stars with microarcsecond precision. A microarcsecond is such a small angle that, viewed from Earth, it could distinguish a coin left on the Moon's surface. Through Gaia's eyes, the galaxy no longer resembles a flat map. It becomes a living structure, stars weaving past one another, spiral arms breathing, clusters dissolving into the night. Distances once blurred become sharp. Hidden motions reveal gravitational currents that shape the Milky Way's destiny. For the first time, humanity sees its home from the inside with the clarity of a cosmic navigator. But Gaia does more than measure. It challenges old assumptions, recalibrates distances that once seemed firm, and exposes subtle distortions in the galactic fabric. Each data release redraws the map of the heavens, reminding astronomers that even nearby stars were misunderstood. Gaia is not just a tool. It is the quiet realization that precision can unravel the false geometry of the night sky. WST, witness to the first light. From the local to the ancient, the camera drifts outward, passing the blue glow of the heliosphere and slipping into interstellar dark. A golden mirror floats alone in the void, delicate yet resolute. The James Webb Space Telescope. Its honeycomb mirrors, arranged like the scales of a celestial insect, capture light that has traveled for more than 13 billion years. What reaches its sensors is not simply brightness. It is history itself, stretched by cosmic expansion into the far-red whispers of distant dawns. JWST is a historian of the universe. Its observations reveal galaxies born when matter was still unsure of its own structure. Their distances, once estimated only through indirect means, now sharpen into measurable form. Redshift becomes not just a number, but a story. How far, how fast, how long. Every image feels like a recovered memory of the cosmos. Fragile star nurseries. First-generation galaxies small as sparks. Infrared arcs lensed by invisible dark matter. Yet even JWST faces the ultimate law of distance. Beyond a point, the expansion of space outruns the journey of light itself. The earliest moments remain hidden behind a barrier that no mirror, no matter how perfect, can pierce. But humanity keeps pushing. Particle colliders, probing the vacuum that shapes the cosmos. The scene shifts to Earth. Rings of steel curl beneath landscapes, circular accelerators buried deep underground. Inside them, particles collide with energies high enough to momentarily imitate the early universe. Why build machines that crash matter into itself? Because the universe's expansion is driven not by galaxies or stars, but by the vacuum that surrounds them. Quantum fields. Invisible, omnipresent, restless. Colliders probe these fields, searching for signs of forces that influence the universe's large-scale behavior. Every new particle discovered, every symmetry broken or confirmed, refines the equations that cosmology depends on to measure distance. For in an expanding universe, distance is not static. It grows, shifts, and accelerates based on the nature of the vacuum. Understanding that vacuum is understanding the fate of all horizons. Colliders offer no images of galaxies, yet they reveal the invisible architecture that determines how galaxies drift apart. Future interferometers, the lunar observatories. Now the camera glides over the moon's pale surface. Craters open like frozen wounds, shadows stretch without atmosphere to soften them. Along the dust, a vision of the future emerges. Interferometers the size of valleys. Laser beams bouncing between stations separated by tens of kilometers, or even across lunar basins. Freed from Earth's atmosphere, these instruments could measure parallax far beyond current limits. Tiny shifts in the positions of distant stars, too subtle for Gaia, would become measurable. Galaxies millions of light-years away might reveal their true motion rather than their redshift-distorted illusion. Distance could be mapped not by inference, but by direct geometry. Such observatories remain conceptual, yet they represent a profound idea. To conquer distance, one must build instruments on scales that mirror the cosmic arenas they seek to measure. Gravitational wave observatories, listening to spacetime. The chapter turns darker, deeper. Black holes drift into view, massive, silent, indifferent. Two of them spiral together in a dance older than planetary systems. Their collision sends ripples through spacetime, waves that spread across millions of light-years. On Earth, detectors like LIGO stretch their arms with near-impossible precision. Future versions, spaceborne arrays like LISA or continent-scale expansions, will detect these ripples with far greater sensitivity. Gravitational waves do not fade like light. They carry unbroken information across cosmic gulfs. Their timing, amplitude, and frequency reveal distances with unprecedented clarity, offering a new cosmic ruler that bypasses the distortions of expansion. In the war against distance, they are humanity's newest allies. The heroic struggle of precision. The film returns to Earth once more. Scientists huddle over instruments, calibrating sensors so sensitive they can detect the thermal expansion of a screw, the vibration of a passing truck, or the faint tremble of a distant earthquake. Every measurement demands an argument against noise, against atmosphere, against distortion, against the inherent chaos of a living planet. Distance measurement becomes an act of endurance, a quiet war fought on the boundaries of human ability. Parallax reaches its final limits. Spectroscopy strains to decode ancient light. Redshift must be disentangled from cosmic acceleration, gravitational warping, and local motion. Every tool is both powerful and incomplete. The universe, vast, hostile, decipherable. The camera lifts from Earth and drifts outward again. Past the moon. Past the quiet orbits of probes. Into the large-scale structure of galaxies glowing like lanterns in an endless night. What emerges is not defeat but determination. Humanity may never travel to the galaxies it measures. It may never reach the stars whose light it decodes. But through instruments of exquisite precision, it extracts meaning from distances once thought infinite. The chapter ends on a silent, steady truth. The universe keeps its secrets behind horizons of enormous scale. Yet each new tool pushes those horizons back, not to conquer the cosmos, but to understand it. And in that understanding, distance loses its power. The silence between stars. Across the deep sky, distance is more than geometry. It is memory. It is delay. It is the quiet truth that the universe is always seen in retrospect, never in its present form. The camera drifts through a field of ancient starlight, each point a message carried across ages. Some belong to worlds long extinguished. Others come from galaxies still rising in the cosmic dawn. Every photon is a survivor of its own journey, older than civilizations, older than continents, older than language. And in the midst of this slow rain of ancient light, a single realization unfolds. Existence is threaded together not by closeness, but by distance itself. Stars sing across gulfs so vast that their voices become faint whispers by the time they reach attentive worlds. Galaxies rotate like colossal memories, turning slowly through eras no mind can entirely grasp. Even the cosmic background, that oldest and coldest echo, offers not a view of the universe today, but a snapshot of what it was before stars had names, before atoms had choices. The scene softens. Nebulae drift like forgotten thoughts. Black holes loom like punctuation marks at the end of cosmic sentences. Space becomes not empty, but contemplative, a cathedral built of time, silence, and unreachable distances. And here, as the universe exhales across millions of light years, a quiet question arises, not spoken, but felt. In a cosmos where everything is separated by distances too large to cross, what does it mean that consciousness exists at all? The final chapter begins, suspended in that breath. Distance has always been the universe's first language. It shapes the curvature of galaxies, the trajectories of wandering stars, the faint glow of worlds that no longer exist. It is the silent grammar of spacetime, a grammar that writes stories across eras rather than pages, measured in repurposed light and long-dead fire. And somewhere within this vast, indifferent architecture, a species rises, looks upward, and tries to understand what it sees. The camera drifts into the void. The final images unfold slowly. A wide shot of interstellar space. Not the crowded brilliance of a nebula, nor the spinning majesty of a galaxy, but the deep, empty dark where distances stretch unbroken for light years. Here, the silence is profound. Not the absence of sound, but the presence of time. A lone star passes into view, its light traveling outward in a quiet, unwavering pulse. By the time that glow reaches any conscious eye, the star may be older, dimmer, or gone. The narration moves like a whisper. The universe is a collection of messages whose senders will never know their recipients. This is the cruel symmetry of cosmic scale. Light as memory, not presence. Every astronomical image, no matter how sharp, is a portrait of the past. Galaxies are seen not as they are, but as they were thousands, millions, even billions of years ago. What is observed becomes archaeology, not observation. A young blue star appears on screen. Its spectral lines shimmer with the promise of youth. Yet the cosmic truth beneath the beauty is sobering. The light leaving its surface now may travel for tens of millennia before touching another world. And any world that sees it will see a version long gone. A star frozen in time, unaware of its own transformation. The universe never reveals itself directly. It reveals only the remnants of what it once was. And in that realization lies a quiet ache, the understanding that everything known about the cosmos is an echo. Nebulae as metaphors for longing. The camera slides through a vast stellar nursery, curtains of gas swirling in slow, multicolored currents. The scene feels alive, like a dream made of light. Yet even these clouds, forming suns and worlds, exist at unreachable distances. Their beauty is a promise delivered late. Stars born within them may one day host life, civilizations, philosophies, but any civilization that looks back toward its own cradle will see only a ghost, a version of its origin already dissolved. Distance becomes a boundary not simply of space, but of memory. What is seen is never what is happening, but what has happened. The cosmos is a museum lit by its own artifacts. Black holes, distortion and the limits of knowing. The scene darkens. A supermassive black hole fills the screen, a glowing ring of plasma swirling around a center where even information cannot escape. This is the ultimate symbol of cosmic silence. Not because it destroys, but because it hides. A place where distance is compressed into pure curvature, where time slows into stillness. A black hole is a horizon of forgetfulness. The galaxies built around such monsters orbit a gravitational memory, a center that never reveals its contents. Even here, where distance collapses, some truths remain forever out of reach. And the narration softens again. Not all distances are measured in light years. Some are measured in the impossibility of seeing past a boundary. Humanity's place in the vast dark. The camera returns to Earth, a pale point hidden beneath the shimmering wings of the Milky Way. The contrast is stark. One small world, one thin atmosphere, one fragile species at the edge of a spiral giant. And yet, this world builds observatories on mountaintops, satellites that hover above the atmosphere, detectors that listen to trembling spacetime. Even in the cosmic dark, the act of understanding becomes a form of light. But the truth remains unchanged. No matter how advanced humanity becomes, it will always experience the universe with a delay. Always reaching backward in time. Always interpreting traces rather than realities. This is not a flaw. It is an invitation. The emotional undercurrent, separation as destiny. Now the chapter enters its most intimate tone. Distance becomes metaphor. Light years transform into reflections on longing, absence, and the unreachable nature of everything the universe contains. Every lost civilization becomes a star whose light still travels. Every vanished world becomes a photon carried across the void. The cosmos is full of goodbyes delivered too late. And yet, in that melancholy, something gentle emerges. A recognition that separation is not a tragedy, but the architecture of existence. Without distance, galaxies would collapse. Without delay, stars could not form. Without cosmic expansion, life would have no time to unfold. The universe protects its stories by scattering them. Time as a companion to distance. The narration deepens as if the camera itself has slowed to reflect. Time is not separate from distance. Time is distance expressed differently. Every meter of space is a measure of how long it takes light to cross. Every view of the stars is a simultaneous view into countless histories. A galaxy cluster drifts into frame, hundreds of galaxies arranged like a frozen storm. Their combined mass bends spacetime, transforming distance into curvature, altering the very path of light. This dance between time, space, and gravity becomes a philosophical truth. The universe is not a place, but a process. Not a stage, but a story, one told across billions of years, with characters separated by gulfs too wide for dialogue but perfect for reflection. The final dissolve, existence as courage. The final minutes settle into near silence. The camera pulls back from the galaxy cluster. Past the filaments of cosmic structure. Past the intergalactic voids that stretch for tens of millions of light years. Past the faint haze of the cosmic microwave background. The oldest light, still cooling, still expanding. The entire observable universe becomes a delicate bubble of memory suspended in darkness. And into this stillness, the closing narration arrives. In a universe defined by impossible distances, consciousness is an act of defiance. Understanding is an act of courage. To look outward is to face the ancient silence and still choose wonder. To exist at all, briefly, brightly, is to join a story written across light years. The screen fades toward pure black. One final whisper. In the vastness, nothing is close. And yet, everything is connected through light. Existence is the journey. and light is the measure of its truth. Fade out. End of documentary.